Okay, so have you ever had that thought where you wish you could just have more control over your brain?
Oh, yeah, totally.
Like, be able to focus better or calm down when you're nervous? Like if you could just flip a switch.
Like a superpower almost.
Exactly. It'd be amazing. Well, today we're going to look into something in the field of neurofeedback that suggests this kind of control might be closer than we think.
Yeah. It's interesting because the human brain, it's always trying to optimize itself. And neurofeedback is sort of tapping into that potential.
That's a really good point. So for people who might not be familiar with neurofeedback, it's basically a way to train your brain. By giving it feedback on its own activity, it's kind of like holding up a mirror to your brain waves,
Yeah.
so you can actually see what's happening.
Right. And the more we learn about this feedback loop, the more potential there is for improving things. Like you said, focus, emotional control, even treating some disorders.
Exactly. It's pretty remarkable when you think about it. We're talking about teaching the brain to change its own patterns.
And the traditional way to do this has been with EEG electroencephalography.
Right, e.g.
It's how we measure the electrical activity in the brain.
Yeah.
And then that data is turned into some kind of feedback. Could be visual cues like a changing image or even sounds.
So it's almost like playing a video game, but with your brain waves.
Yeah, exactly. You try to hit those targets.
But there's a catch, and this is what makes today's deep dive so interesting. There's a sort of lag in a lot of these systems.
Latency is the big thing.
Yeah, latency. So today we're diving into a new development that could really change how we think about neurofeedback. And it all comes down to timing.
The research we're looking at is from the National Research University Higher School of Economics.
Okay.
It was published in the Journal of Neural Engineering.
Yeah.
And it tackles this problem of latency in the feedback loop.
Yeah.
Timing is super crucial here.
So let's break that down. Latency,
Yeah.
in simple terms, what exactly are we talking about?
Well, latency is basically the delay between your brain doing something and you getting feedback about it.
Okay.
Imagine you're trying to learn to shoot a basketball, but you're blindfolded. And you only find out if you made the shot, like seconds later.
That sounds incredibly frustrating.
It'd be near impossible to improve, right?
Yeah, you'd have no idea what you were doing right or wrong.
Exactly. And unfortunately, that's the same problem a lot of current neurofeedback systems have. This delay issue, the feedback you're getting. It might not be totally in sync with what your brain just did.
So the brain's trying to hit a moving target, but it doesn't even know where to aim.
Right. Which is why getting consistent results with neurofeedback has been a challenge.
That makes a lot of sense. So what did these researchers do differently?
Well, they came up with a new mathematical method to filter EEG signals.
Okay.
And this allows for almost instantaneous feedback. We're talking less than 110 milliseconds.
Wow, that's incredibly fast. So how does that kind of speed actually affect things? Does it really change the way the brain learns?
It seems like it does. This level of speed. It means the feedback feels much more integrated with the brain's own processes, like it's getting real-time coaching.
Oh, wow. So it's not just seeing a graph or hearing a sound that says good job. It's about the feedback being so precise that your brain can actually feel that connection and adjust in the moment almost without you realizing it.
Exactly.
Mhm.
It's kind of like when we learn physical skills. We don't think about every single muscle movement.
Right.
It happens subconsciously through practice and feedback. And this research suggests we might be able to tap into that same process. But for mental skills,
This is really interesting stuff. So to test this out, they did an experiment, right?
they did. They worked with 40 subjects.
Yeah.
And they trained them to increase the power of something called their parietal alpha rhythm.
So for those of us who don't spend our days thinking about brain waves, what is parietal alpha rhythm? And why would we want to increase its power?
You know that feeling you get when you're really focused on a task, but you're not stressed or anxious?
Oh, yeah.
That's your parietal alpha rhythm at work. So increasing its power, it's like strengthening that calm, focused state of mind.
Okay, that makes a lot more sense. And how did they actually go about training people to do this? Did everyone get the same type of feedback?
So they divided the subjects into 4 groups.
Yeah.
One group got feedback with the shortest delay possible, about 240 milliseconds.
Okay.
And they've actually been able to reduce that even further since then.
Wow.
The other 2 groups got artificial delays of 250 and 500 milliseconds.
Okay.
And then, of course, there was a control group that didn't receive any real feedback.
The classic control group. So what were the results? Did that faster feedback actually make a difference?
It did. The results were really pretty amazing. The group with that minimal delay, they learned way faster than any of the other groups.
Really?
Yeah, they needed fewer sessions to reach that target alpha power. So it seems like that really tight feedback loop made the training a lot more efficient.
So faster feedback equals faster learning. That makes sense. But did the changes actually stick around? I mean, we don't want them to just disappear once the training's over, right?
That's a really important point. And it's what makes this research so exciting. What they found was that the minimal delay group was the only group to show a lasting increase in alpha power, even after the training stopped.
So that suggests that the quick feedback could be the key to getting those long-term benefits.
Exactly.
Wow. If this is true for other types of brain training too, this could be huge. I mean,
Yeah.
think about what it could mean for improving things like focus and memory, or even treating neurological
It's
disorders.
pretty mind-blowing, right? Instead of just managing symptoms, we might be able to actually train the brain to rewire itself.
Yeah, and in a lasting way.
Exactly. And think about the potential for enhancing things like focus, creativity, emotional regulation.
Yeah.
What if we could all happen to those abilities more easily?
That's incredible. It feels like we're talking about unlocking a whole new level of human potential. I can see why you're so excited about this.
I am. This discovery, it just fits so perfectly with what we're learning about brain plasticity. The brain's ability to change throughout our lives. It's constantly rewiring itself based on our experiences. And this research really suggests that giving the brain the right feedback at the right time can have a huge impact on that process.
So it's not about forcing the brain to change, but more about creating the best conditions for it to learn and grow naturally.
Yeah, like giving it the tools it needs to learn better.
That's a great way to put it. And if we can use this technology the right way, imagine what it could mean for society as a whole.
Right. What if everyone was better able to handle stress and focus their attention and regulate their emotions?
It sounds kind of utopian, but it's a really fascinating thought.
It is. We do need to be careful not to get ahead of ourselves, though. There's still so much more research to be done.
Of course, but these early results are definitely promising. And it's interesting that this breakthrough came from something so simple, yet elegant as reducing latency.
It just goes to show the power of scientific ingenuity.
It's a good reminder that sometimes the biggest breakthroughs come from focusing on the fundamentals. In this case, that fundamental is understanding how the brain learns best.
Exactly.
Yeah.
By getting that feedback loop, right?
Yeah.
We're essentially giving the brain what it needs to become a more efficient learner.
So let's bring this back to our listeners.
Yeah.
If you had the opportunity to train your brain with this kind of precision, what would you want to improve and why?
It's a great question. Would you want to boost your focus, maybe get more creative, or even strengthen your resilience? What impact do you think that would have on your life?
It really is amazing to think about all the possibilities. And as this technology continues to develop, it's worth thinking about not just the individual benefits, but also what it could mean for society as a whole.
Absolutely. These are powerful tools, and we need to have open conversations about how to use them responsibly.
That's a great point. As we learn more about the brain, we need to make sure we're using that knowledge ethically.
Right. Scientific progress and ethics need to go hand in hand.
So where do we go from here? What does all of this mean for the future of neurofeedback? So it really feels like we're on the edge of something huge here with this new development in neurofeedback.
Yeah, cutting down that lag time. It seems like they've found a way to make brain training way more precise and effective.
And we've covered a lot of ground today, haven't we? The science behind it all, the potential benefits, and even some of those bigger questions about what this tech could mean for society.
It's exciting stuff. But like with any new frontier, we need to be thoughtful about how we move forward.
Exactly. So as you're listening to this, think about what part of your own brain power you'd be most interested in boosting.
What would you want to improve?
And how do you think even small changes could impact your life and maybe even the world around you?
It's a fun thought experiment, isn't it? This technology is still in its early stages,
Hmm.
but those individual benefits in the bigger picture, it's all worth considering.
Absolutely. Well, this has been an incredible deep dive. I think we've only just scratched the surface of what's possible.
Yeah, we have.
This whole idea of tapping into the brain's true potential, it might be the most exciting frontier we have yet to explore.
Who knows, maybe one day we'll all have those brain-boosting superpowers.
Maybe we will. Thanks for joining us, everyone. We'll see you next time.